To begin our chapter on angles and triangles, we need to first review some skills on different types of angles. First, we're going to start with adjacent and vertical angles. Adjacent angles are when angles share a wall or a side. So they're right next to each other on a figure. So let me move this over a little bit. So angles share a wall or a side. So what I'm going to do is draw an example of angles that you might see, and then we'll talk about what the kind look like. So here is our four angles that I've created with an X, and we're going to label it A, B, C, D, and in the middle here is going to be E. The angles that are adjacent or they share a wall would be angles such as angles AED and angle DEC. That would be these two angles right here, and they share the wall or the side of D, so those are adjacent to each other. Now let's talk about vertical angles. Vertical angles are angles that are directly across from each other. So they don't share a wall or a side. They are just angles that are directly across from each other. So let me draw my X again with the same names, A, B, C, D, and E. All right, so the angles that are vertical from each other are angles such as AEB and angles ADEC. So we have AEB right here and DEC. They are directly across from each other. Another interesting point to say about vertical angles are always congruent or identical. So if we know what one is labeled, so let's say that in our bottom example, we have that this is 110 degrees, then we also know that DEC is 110 degrees. They're always congruent, identical. Now we're going to work on some examples. First, for each of these, we're going to decide whether these are adjacent angles or vertical angles, and then we have to find out what the value of X is. So we're going to go through and write first if they're adjacent or vertical. For the first example, they are right across from each other, so they are vertical. All right. And then in the middle example, those two share the wall right here that's in between them, so they're adjacent from each other. And then on the very last one, it is another vertical situation where they're right across from each other. Now we have to find the value of X. So with vertical angles, as I have mentioned before, the two angles are equal to each other. They're identical, they're congruent. So for this first example, we know that the 50 degrees that are on the left is also equal to the X degree. So because we know that X is equal to 50. They are the same amounts, the same degree measures. I'm going to skip over to the very last example just to keep going with our vertical examples. So just as I set up before, we're going to set up a little equation. So I know that the 120 is going to equal the other angles, which are X plus 8. Okay, these two angles have to equal each other, but we have to find out what X is. In order to find this one-step equation and find out what X is, we have to get X by itself and get rid of the 8. In order to cancel out the 8, you do something to both sides of the equation, the opposite operation. Since 8 is being added, you're going to subtract the 8 from itself, but then also have to do it on the other side of the equation. The equal sign is important. It tells you you have to do something on both sides of the equation. So on the right side of the equation, 120 minus 8 is 112. And then on the right side of the equation, we have 8 minus 8, which is 0. It crosses out, and we're left with just X. So X is equal to 112 degrees. Now, remember, our two angles here have to equal each other, right? So let's plug it in. We have our X, which is 112, plus 8, and we hope that it equals the other vertical angle, which is 120. Well, when I do 112 plus 8, it is 120. So we know that our two angles are congruent or identical. So again, x is equal to 112, and that made that happen. Now let's go to our middle example. We have two angles, and then it shows that they have to add to make 90 degrees. So we need to add them together. We have the angle of 43, and we have x plus 3, and we have to make sure it equals 90 degrees, or a right angle. So what I'm going to do first is I'm going to combine my like terms on the left side of the equation. 43 plus 3 is 46, and then I bring everything else down, plus x equals 90. Now, just like we did in the previous example, I'm going to draw a wall where my equal sign is, and I have to get the x by itself. So the 46 has to go. The 46 needs to turn to 0. So the operation to do that is to subtract 46 and make it 0 or cross it out. But I have to do it on both sides of the equation. Things have to stay equal. So I subtract 46 also from 90. So what we're left with on the left side is x equals, and then 90 minus 46 is 44 degrees. Okay, so we have x is equal to 44 degrees. Now we have to check our answer. So we need this 43 degrees and this x plus 3 to all equal 90 degrees. So when we found that x was 44, this turns into 44 plus 3, which is 47, right? So we now have an angle of 47 and an angle of 43. So if I add those together, I have to carry the 1, and it becomes 90 degrees, which is what we wanted right from the start. Remember that square counts as a right angle, which is 90 degrees. So we know we got our answer correct. Complementary angles and supplementary angles are also angles you've learned in the past. Complementary angles are angles that add up to equal 90 degrees. So in our last example that we talked about, we had angles and then this right angle, and these two angles have to add up to be 90 degrees. I'm going to call them angles x and y. Both of them have to add up to equal 90 degrees. That's complementary. A supplementary set of angles are angles that add up to equal 180 degrees. That's a straight line. So a lot of the time you see the straight line underneath, and then you see angles such as that. So this angle, we're going to call it A, and this angle, B, have to add up to equal 180 degrees. On these examples, we're going to state whether they're complementary or supplementary first, and then we're going to find the value of x again. So let's label them first. On the first example, I see two angles that open to a straight line. That means it's supplementary. On the second example, I see that 90-degree arrow or square, and that shows it's a right angle, so that means it has to add up to 90 degrees, which means it's complementary. On the last example, I see, again, a straight line, which means that these angles have to add up to a supplementary angle. Now to find the missing part, which is the x. So if they're supplementary, remember, they have to add up and they have to equal 180 degrees. So let's add up our two angles over here on the first example. We have an x, and then we have an x minus 6. On this example, we need to combine our like terms first. An x plus an x creates two x's, all right? And then we subtract 6, and we have 180. Now I like to build my wall. We need to get the x's alone. The first thing we're going to do is get rid of this 6. It's a minus 6, so we're going to do the opposite action, which is adding 6 to both sides. We're left with those crossing out, and a 2x equals 186. Now, the question is, how do we get rid of that 2 that's right next to the x? If a number is with a variable, like it is right there, that means they're multiplying. So what we have to do to both sides of the equation is divide by 2. Well, on the left side, 2 divided by 2 is 1, so we cross it out and we're left with an x. And now we do 186 divided by 2. That answer is 93 So we just found out that x is equal to 93. Let's check our answer. If we have this first x as 93 degrees, now we have to do 93 minus 6 over here. That is 87 degrees. Remember, they both are supplementary angles, so they have to add up to equal 180. So 93 and 87 are going to add up, hopefully, and they do. They add up to be 180 degrees. So we know we got our answer right, and that x is equal to 93 degrees. That is the same way of answering the third example with our supplementary example. So I want you guys to try that on your own. I'm going to go ahead and do this complementary middle problem with you guys. Because they're complementary, remember these sides have to equal 90 degrees, a right angle. So both sides add up to equal 90. So we have an x minus 8 and a plus 20. Now, we have to put all of our numbers together on the left side of my equation. Now I want you guys to look at this. It says minus 8 plus 20. I don't like subtraction, so I'm going to do keep, change, change. Now I'm left with a negative 8 plus 20. In order to solve that, you just do 20 minus 8, and the answer is 12. So we're left with x plus 12 equals 90. Now we have to get the x by itself. In order to do that, 12 has to do the opposite operation. It was being added, so we're subtracting 12 from both sides. The x is equal to, because our 12s cancel out, the x is equal to 78 degrees. Now, we have to make sure we check our answer. So, if I plug in a 70 where the x is over here, or 78, I'm sorry, 78 minus 8 is equal to 70 degrees. So the bigger angle of the two is 70 degrees, and then we have 20. So if we add 70 and 20 together, it should equal 90, and it does. So we know we checked our answer and we got it right. X is equal to 78 degrees. Try this third one on your own. It is just like the first example that we did.